Okay, for our third part of our series on interpreting odds, risk, rate, and hazard ratios, we're going to do a second round of practice. And in this next round of practice, we're going to focus on determining whether or not things are statistically significant or not and how to interpret p-values. And we'll do that for a hazard ratio example at the end as well. So, when we have numbers like this, we can quickly just look through the first numbers to make an initial determination of something of whether it seems to be harmful or protective. Numbers that are above 1, do you remember if they're harmful or protective? You should. So numbers that are above 1 are generally viewed as harmful. More exposure, more disease. So we can quickly go through these and look at whether or not it suggests if they're harmful or protective. 1.5, it's greater than 1, so it's harmful. 1.2, it's greater than 1, so it suggests harmful. 0.6, that is below 1, so that suggests decreasing disease as exposure increases. So those things are protective, like eating fruits and vegetables and heart disease, or wearing your seatbelt and dying in a car wreck. Those are protective exposures. They suggest protective. Numbers where they're above 1 suggest more exposure, more disease, or more death. So that is harmful. Numbers below 1, like 0.35, are protective. Above 1, like 1.45, harmful. But that's not enough. Those would just be our 2x2 tables. We need to take into consideration sample size and all these other things to determine whether or not we're 95% confident if something is harmful or protective. We want to be confident in our statements and our decisions. So something that has an odds ratio of 1.50 initially seems to be harmful, but when we look at the confidence interval, it ranges from 0.8 to 2.5. That is protective, that is harmful. 1 is included in this confidence interval. Since there is a chance that this exposure, from whatever it might be in letter A, is protective, and there is a pretty good chance as well that it's harmful, we are 95% sure that the true odds ratio lies between 0.8 and 2.5. It could be protective, it could be harmful, so there's really no statistically significant difference between the exposed and unexposed groups. So there's nothing significant. 1 is included in the odds ratio's 95% confidence interval. If 1 is included in this range, it's not significant. Same thing, is 1 included between 0.6 and 1.8? Yeah, 1's included. So again, it's not significant. Now in this example, is 1 included between 0.4 and 0.8? I don't see 1 included in there. There's 0.5, 0.6, 0.7, 0.75, 0.78, but no number 1. It's all below 1. That's protective, that's protective. Since 1 is not included, it's statistically significant, and the whole thing is statistically significant, and it's all protective, so it's significantly protective. 1.32, it's all above 1. The whole confidence interval is above 1, so it's significantly harmful. This one is a borderline one, 0.1 to 1.0. 1 is actually included in the actual confidence interval. This is definitely protective. That is not harmful, but it's right on the edge. It's borderline protective. We'd have to look at the p-value to make an actual determination. If it's 0.05, then it's not significant. If it's 0.049, it's significant. If it's 0.051, it's not significant. The last one, letter F. 0.12, that's harmful. 1.8, that's harmful. The whole range is above 1. The whole thing is harmful. There is a significant effect. It is significantly harmful. Lastly, we need to do p-values. You should be able to read p-values from these odds ratio estimates, or at least make a an interpretation of whether it'd be above or below 0.05. You're not going to be able to make a determination of exactly what it's going to be, but p-values need to be between 0 and 1, or between 0% and 100%, and we can figure out if it's going to be above or below 5% by just looking at these numbers. So 0.8 to 2.5, that is not significant. Things that are not significant, there's no significant effect, have p-values that are greater than 0.05. If we were to say that that is harmful, there would be a greater than 5% chance that we would be wrong. So it's not significant. 0.6 to 1.8, that suggests protective, that suggests harmful. 1 is included. We know that it's not significant. The whole thing is not significant. So since this is not significant, the p-value again is greater than or equal to 0.05. There's a greater than 5% chance that that this estimate of it being harmful is not always going to be the case. What about in this example? We're 95% sure that it is between 0.4 and 0.8. How sure are we that it's protective? Well, we're at least 95% sure that it's all protective. So there's a less than 5% chance. P is less than 0.05 for things that are statistically significant. There's a less than 5% chance that this is not significant. So this is a significant group of numbers here. 1.1 is harmful, 1.7 is harmful, the whole range is harmful. We are 95% sure that it is harmful. There is a less than 5% chance that it's something otherwise. So there's a statistically significant difference. Things with statistically significant differences, things that are entirely harmful or entirely protective for that confidence interval, have p-values less than 0.05. When 1 is included, and it's exactly the number 1, or it rounds to 1.0, that is going to make it a little more difficult. So this is on the borderline, as we said earlier. So the p-value is going to be 0.05 or something very close. This one, the whole thing is above 1. 1 is not included in the range. There's a statistically significant difference between the exposed and unexposed with regards to the odds of disease. So there's a significant effect. Things that have statistically significant effects have p-values less than 0.05. So that is significantly harmful in this example. So what about these odd scenarios here? Well, 1.1, and then you have this confidence interval 1.3 to 3.0. This suggests harmful, but 1.1 has to fit in that range. If you get a scenario like this, this is a mistake. Somebody screwed up. The peer reviewer screwed up if it's a journal article for not catching it, as did the authors. So this is a mistake. 0.8, it's above the whole confidence interval. That can't be. That's a mistake. 0.8 here, again, it's not included in that confidence interval. Something's wrong. That's a mistake. All right, let's try some of this analysis with hazard ratios and a real study. So there was this real study done in the journal Stroke. That's the name of the journal. It's a high-impact journal. It was looking at sugar drinks and diet soft drinks, artificially sweetened drinks, and the risk of stroke and dementia, and they did a cohort study. Fairly recent publication, and there's the actual title for you if you want to pause it and read it. And they have a variety of tables, such as this one. I'm going to cut out some pieces of it and zoom in to the high points here for us for this little practice. So we were looking at the risk of all-cause dementia, so dementia from any type of disease, as well as the risk of Alzheimer's disease-associated dementia. And then they were looking at the effect of artificially sweetened soft drinks, like diet soft drinks, on the risk of all-cause dementia. They have their comparison groups. They have the reference group or the control group, the no exposed group. These people had 0 drinks per week. Then they had the moderate exposure group. They had 0 to 6 drinks per week. And these people had 7 or more drinks per week. They had at least 1 diet soft drink or more per day. People like me. And they had 2 different models. These models they were different adjusted hazard ratios, so they had different confounding variables they were looking at. And then the outcomes, they did models for all-cause dementia as well as Alzheimer's disease-associated dementia. So what did they find out? And then I got these p-values here blocked out so that you can't see them. So we're going to first go through and see if these are significant or not significant. So my first question is 0.79 to 2.43 significant or not? So initially it seems harmful. All these numbers are all above 1. They all initially seem harmful. Well, that one seems like there's nothing going on at all initially. But with the hazard ratios confidence interval, which ones are significant? Well, this one does not include 1, or does it include 1? That's protective, that's harmful. We have conflicting evidence. 1 is included, so that's not significant. What about this one? Well, it's all above 1, so it's statistically significant. There's a significant association between artificially sweetened drinks and all-cause dementia, so that's significant. Let's look at the model with different confounders. 0.6 to 1.67. 1 is included, not significant. 0.54 to 2.17. Is 1 included? Yes, it is. So protective, harmful, both sides of the confidence interval. 1 is included, not significant. 1's included here in our risk for Alzheimer's disease in this group, so that one is not significant. Here, the whole thing is all harmful for those who drink 1 or more per day and the risk of Alzheimer's associated dementia. So that is all above 1. 1.0 is not included, so that is all harmful, so that is significant. 0.59 to 1.87 has numbers on both sides of 1. So that's protective, that's harmful. 1 is included in the middle there. Whenever 1's included, there is no effect. It's not significant. Again, 1 is included here, so what do you think? It's not significant. So what p-values might we expect for things that are not significant or significant? So what p-values might we expect? Well, this one is not significant, so we would expect our ability, if we said that 1.39, which at face value looks harmful, if we said it's harmful, what would be our risk of being wrong? Well, if it's not significant, the risk of being wrong is going to be greater than 5%, greater than 0.05. So is it greater than 0.05? Yeah, it's actually 0.25. That's not statistically significant. What about this one? That's entirely harmful. 1's not included, so it's significant, and things that are significant have p-values that are less than 0.05. So that's 0.03. That's statistically significant. This one, 1 is included, so it is not significant. P is going to be greater than 0.05, so it's 0.99. It's about as high as you can go as not significant. All right, 0.54 to 2.17. Again, not significant, greater than 0.05. 0.78 to 2.82. 1 is included. It's not significant, greater than 0.05. This one, the whole range is all harmful, so it's definitely significant. The p-value would expect is going to be low, lower than 0.05, so that's significant at 0.02. These last two, both of them include 1, so they're both going to be not significant, both greater than 0.05. So that's a little run through. If you have further questions or anything, or have any questions, feel free to email me at jason.marion@eku.edu. I hope that this has been helpful. You can watch these videos a few times to go through them, and I hope you do well on your exams, and thank you.